Hi and welcome everyone to this security meetup. Today we will talk about common security pitfalls in Spring Web applications. First of all, I would like to introduce myself. My name is Marth and I'm a software developer and penetration tester at a company called Cloudflight. You might know this company by its former name Catalyst. Recently we joined forces with SBA Research to further organize this meetup series. So what can you expect from this talk? Well, first of all, I would like to emphasize that we're not talking about bugs in the framework itself. It's what I, as a penetration tester, consider to be common security pitfalls when using Spring, which could be, for example, unexpected default configurations, kind of hidden features, and complex framework internals. We'll demonstrate some of these pitfalls on example applications. Although we cannot give a full introduction of the Spring framework here, we will just add some very general notes for those of you who have never worked with it. It's an application framework for the Java platform, and to quote its website, Spring makes programming Java quicker, easier and safer for everybody. Spring's focus on speed, simplicity and productivity has made it the world's most popular Java framework. There are also several extensions like Spring Boot, Spring Security, Spring MVC and Spring Data. And I would like to emphasize that we are not blaming Spring here for these pitfalls. This is just our observations from our penetration tests. So first example is the output restriction. I will show you my IDE now. So I'm showing you a very simple REST controller here, which declares a user repository here as a hash map for simplicity, and just adds this user object inside the constructor. So this user object is created by an ID, a name and a password. Additionally, we provide a REST endpoint /user/ID, which can be used to retrieve the created user objects. So what does a user look like? Well, we decided to go for the XML format, and of course, as you might have already noticed, a password is not something you want to send to the browser of the user. That's why we are using the XML transient annotation here to skip this field in the serialization when sending it to the client. To show what this looks like, I will open the application in my browser. So you see my browser window now, and if we have a look at the source code of this page, we will see that it's truly of XML data, and in fact the password field was skipped just as we desired it. So what might come as a surprise for some is that Spring by default doesn't only support the XML data format to be returned, but also the JSON format. So there are multiple ways to request a different content type from Spring, but the simplest is probably to just modify the accept header and set it to application JSON. Once we submit this request and look at the response, we will notice that we truly get JSON back, again with ID, name, but this time also with the password. So what might not be so obvious in the first place should be pretty understandable when looking again at the annotation. We're using XML transient here, which is an annotation specific to the XML data format, and is of course simply ignored by the JSON serializer. So how could one fix this? Well, the simple solution would be to just add another annotation for the JSON format here, like for example JSON ignore. Or another solution would be to go to the controller and restrict the produced content type with the producers attribute, or to just restrict the produced content type just globally. Another solution I would consider a safe way is to create a separate class which fully omits this field with the sole purpose of being sent to the client. We will switch back to the slides for now. As a summary, one can say that there are probably two very common data formats. One is XML, the other one is JSON, and there are different libraries to serialize data into these formats, which require or respect different keywords and annotations. So some libraries might consider the transient keyword of the Java programming language. Another library might consider the JSON ignore annotation or the XML transient annotation, just as we saw in our example. However, another XML library might use the extreme omit keyword here, extreme omit annotation of course here. So the attack just consists of requesting a content type that was not considered by the developers when implementing the filtering. Possible solutions are to restrict the content type either globally or just for the controller method, or to use a separate class. This means more or less filtering manually. So the second example we want to check is a custom validator. Again, I'm switching to the IDE here. And we have a simple command line based main application here, which constructs a Cloudflight user from the command line arguments. After this Cloudflight user was constructed, a validator is used to see if there were any constraint violations here. If there were any validations, the error messages are printed to the command line. So, what does a Cloudflight user look like? A Cloudflight user simply has an email address which is validated indirectly via the Cloudflight email annotation. So if we have a look here, we see that it has the constraint annotation and it provides the Cloudflight email validator class as a validator. So this is where the actual validation happens, because this class derives from constraint validator and overrides the isValid method. This is where the real logic happens of the validation. So we first check here if the email address is null, and if it's that the case, then we add an error message. Next we check if it's shorter than 1 character, and if that's the case, we add an error message. Finally, we check if the email address has a valid email suffix. So what are valid email suffixes? Cloudflight initially consisted of the two companies Catalyst and Crisp Research. So this meant in the beginning that valid Cloudflight email addresses were cloudflight.io, catalyst.cc or crispresearch.com. So every Cloudflight email address must have one of these suffixes. So to see what this application looks like, I will show you my terminal here and just call the application from the command line and pass test as an email address. Of course, it says the suffix is missing, and we could use, for example, test at catalyst.cc. So if we are using this example as input, the application will say this is a valid email address. So where is the issue now? Well, the issue is actually intentionally a bit hidden, and it's this very simple add error message function, which you never saw anywhere here, which is actually derived from the validator class, which we put on purpose here to kind of hide this build constraint violation with template method from the validation API, which actually adds the error message to the list of violations. So what's the problem with this, with adding this message to the violations? Well, it says it's with template method. This means, or in this case, this means that this error message is actually interpreted as a Spring expression language string. So if we pass an expression language string here, like 1 + 1 in the brackets for the expression language, as in return we will get 2. This means this was actually processed by the expression language engine here and successfully calculated. Of course, simply adding up 2 numbers is not what we want to do with a cool and regular exploit. So our goal in this case for this demo is to actually execute code. However, the syntax of the Spring expression language is a bit limited here. We cannot just use regular Java syntax to be executed, because what we would like to do is probably something like runtime get runtime exec pvd get input stream, and we would wrap this around the scanner. Oops. next line, and then we would get the output of the command to be printed to the command line. However, in Spring expression language, we cannot just use new to instantiate an object, and we just cannot use access the runtime class here. So we have to, well, find our way around to create these objects with reflection. And how to do this, well, will be easiest to find out with the debug mode of the IDE. I just started this up, and now I will switch to the evaluate expression window, which makes it a lot easier. So what do we have in the Spring expression language? We of course always have a string, and we can use the getClass function here, and we can use it to resolve other classes via the class loader. For example, we want to get for now the runtime class, and we want to call the getRuntime method. So we will have first a look at all methods via reflection, and we can see that the getRuntime method is at index 6. And finally, we want to invoke it with a null parameter. And now we have a runtime where we can call exec pwd on it. And we get a process object which shows that we actually executed this, or at least created a process for it. So now for the scanner before we had before, we can actually do the same thing. Can do class for name Java util scanner. However, this time we want to create an object for this. This means we need the appropriate constructor, and we want to the one that's accepting the input stream, which is at index 8. And we want to create a new instance for this. So, and of course it lacks the parameter here, the input stream, and this is where we add the command we had before. Get input stream is added here. This means we have created a scanner on which we can now simply call next line, and we really get the output of the command we wanted to execute, of the pwd command. So switching back to the terminal, we can add this here, and you saw that it failed the first time, but I executed the very same thing on the second time. Well, the indices I'm using are not constant between the runs, and of course also not constant between JDK versions. So it might be very well that you have to play around with the indices and have different indices than I have in my demo. And also, if it doesn't work on the first try, just execute it a second time and it will maybe be successful in that case. So I'm just stopping this and switching back to the presentation. So we had kind of a hidden expression evaluation here. From the type of attack, I would say it's more or less a classical injection. We cannot fully make use of the Java syntax we are usually used to, but with some kind of reflection tricks, we can probably find our way around and even execute code. And well, what are the possible solutions? It's the easiest probably is to avoid user input invalidation messages at all, or to do some escaping, for example with the dollar and the curly brackets. Strictly speaking, this issue is not caused by Spring itself. Well, this whole validation stuff is part of the Java Enterprise Validation API, and Spring Boot just drags in the reference implementation by Hibernate as a dependency. So it's not fully the fault of Spring that this is possible. So the next one is about dependencies. So I'm again switching to my IDE and simply starting up the application. So taking a look at my browser, you can see that I prepared some credentials for this application here. And if we log in, we will immediately be greeted as a user here. So what's the issue with this one? Well, actually it's a single line that makes the difference here. I added the Java Melody dependency to my Gradle file here. And Java Melody is a rather nice nice library to do monitoring of endpoints and so on. However, by default, we can see that as soon as you're logged in, you have access to the dashboard. And there's a lot of information about the resource usage. You can have a look at the Spring Beans, you can look at the processes running on the server and so on. So you can do a lot of nasty stuff here. So as a demo, I'm using a second browser to log in with the second user, and switching back to the Melody dashboard, we can have a look at the HTTP sessions, and I see that there are 2 users logged in here. And if I simply modify my cookie and go back to the greeting page, I see that I simply hijacked the session by copying the cookie, which I found out by looking at the monitoring dashboard. So switching back to the presentation. So what was the issue? It was rather easily to add the dependency and forget about that there are additional endpoints exposed, which might add some functionality for users which are not intended to have these permissions. So the attack of course depends on the added dependency itself and what functionality is provided. And the solution is to make sure all exposed endpoints are protected by Spring Security or whatever authentication authorization system you're using in the backend. So well, you might ask, so how do I find out what endpoints are exposed? Well, the Spring Boot actuator actually provides an endpoint which shows all the mappings in the application. But some libraries, for example, also Java Melody, might use filters to implement their endpoints, which are not shown in the actuator, so you need to be careful with that. So to the last demo for now, I will show you an example that's quite similar to the first example of the output restriction. Again, we have a user controller which has a /user/id endpoint, which allows to query users by the ID. But this time we wrapped it simply by a user service, because having a look at the web security configuration, we configured the /user endpoints to be accessible by all users without even being logged in. Naturally, we also have this password attribute field here. However, we got rid of all these nasty XML annotations and so on, and we decided to have this kind of protection here inside the user service by adding the roles allowed annotation here that says that only administrators are allowed to call this method. So starting up this application, we will see what this exactly looks like. So here you see my browser window, and still again you see that there actually was a user returned, although we are not even logged in, so this means we definitely don't have the admin role here. So why was this not working? So looking back at our controller, we can see that we directly instantiated this user service. So a lot of the magic that Spring is using, like this roles allowed annotation here, and also related stuff like the database transactions and so on, rely on aspect-oriented programming and proxying. However, it's not possible to use a proxy when the object is instantiated manually. So this means to fix this, we have to fully rely on the dependency injection mechanism that's provided by Spring, which we're doing by adding the auto-wired keyword here and expecting the user service to be a parameter to our controller. So this way, this instance is managed by Spring, and the proxy is installed correctly. So if we restart the application, and after that do the same request again, so we see that finally now we are rejected to access this page, just as we would have expected at first. So to sum this up, much of the magic behind Spring depends on proxying and aspect-oriented programming, which is not active when you're manually instantiating objects with new, or the same is true when you're directly calling methods of the same class directly. The solution is to always use the dependency injection mechanism when relying on annotations, no matter whether it's security or database transactions or whatever. So that's it so far. I hope you learned a lot today, and I hope to see you at the next meetup. See you!